Thanks for attending. I know it can be quite hectic over 2 days to learn a lot, so I'll try and keep this interesting. And I'm going to speak to you about authorization. So if you've ever used a Google product at any point of time, this is what's happening behind the scenes. And let me introduce myself. My name is Sohan. I'm originally from India, but I'm settled in Amsterdam. Flew in yesterday and for the conference. So yeah, I'm very excited to be here. And yeah, have more than 16 years of experience in the industry, mostly in the cloud. I'm not a Java expert, so if you have any Java-specific questions, I might not be the person, but I've worked a lot in the cloud, including at AWS and a bunch of other startups. So that's where my expertise lies. I'm going to start with a quiz question, a trivia question. If you know the answer to this, you might be old, right? I'm warning you. But does anyone remember this website from, I think, 2011, 12, around that time? Yes. You must be Generation Z. Do you use TikTok? Yeah. No. So, yes, this was officially called Google+. And people also called it Google Circles. And it was Google's social network. So they tried to make a social network like Facebook. The younger people in the crowd are like, what's happening? I've never even seen this before. The idea was, instead of having a feed where everyone could see everything, you could put people into a circle, right? So you could put university friends, or you could put family, and you could share things with certain people. No one uses this anymore, right? Absolutely no one uses this. But the interesting thing is, what came out of it is Google changed how they did their permissions and authorization behind the scenes in their backend. And that's basically what I'm talking to you about. Because if anyone here has used Gmail, has anyone used Gmail? Everyone, yeah. I'm going to ask lots of obvious questions today. If anyone has sent a Google Docs link in Gmail, you might see this, right? If you're sharing a document with someone, you might see, like, does this person have permission to use this? And if you think about it, this is kind of like magic, because Gmail and Google Docs are two separate apps. But there is a central authorization check in between the two. So how this works is what I will explain to you. Before that, a quick intro lesson on authorization. In the IT industry, we use the word auth to mean both authentication and authorization. And both are they're two separate things altogether. Authentication is identity. So who you are. So when you've used Okta or LDAP, it says, okay, you are this person. I'm Sohan. Cool, you can get in. Authorization is what comes after that, which is permissions. Once we know who you are, what can you do? Can you edit this document? Do you have access to this repository? Can you see this file? And so on. So I will be talking to you about authorization. In the past, we have used things like access control lists. One big list which will say all these people can edit this one document. Say you create document number 2. Have another list. All these people can read this document. All these people can edit this document. Not the most scalable. So the industry basically came up with something called ReBAC, or role-based access control. Has anyone heard of ReBAC? I'm sure all of you have this in your company. So you will be tagged to a role like software engineer. And only software engineers can check in code. Or maybe someone is tagged to sales, and only sales can check sales reports. The thing is, this doesn't scale beyond a point. It can get very complicated. What if the sales guy wants to check in code? Doesn't happen always, can happen. So you have to create a new role. And in a complex industry or a complex environment, this does not scale. So things change to attribute-based access control, where everything has a characteristic or an attribute. So my IP address, my location, my team, all of these are attributes. When a decision has to be made, it checks all of these attributes and gives you a yes or a no. Also can get very complicated at scale. You're managing hundreds of attributes and you're parsing through all of that for a decision. Now, Google basically operates at the scale of Google, which is billions of users, millions, even more, millions of billions of documents, YouTube videos. So for them, none of this worked. It didn't scale. So they popularized this new thing called relationship-based access control. And we know exactly how they did this because in 2019, they released a white paper where they describe exactly how they do their authorization. So if you like reading technical papers, check it out. It's only 14 pages and it's quite readable. It's not very scientific. And they describe in depth exactly how their internal authorization works. Both their internal authorization and the paper is called Google Zanzibar. And in it, they describe everything, right? How the API works and so on. In 2019, they said they could do 10 million client queries per second. I'm sure that number has increased since then. So you can imagine what scale they operate in. And this paper really popularized this concept of ReBAC, or relationship-based access control. So let me give you an example of what that is. So instead of roles and attributes, everything is based on relationships between one another. So say you have a document. The document exists in a folder, so there's a relationship between the document and the folder. Say you have a user here who can access this folder. There's a relationship between the folder and the user. And therefore, there's a relationship between the document and the user. So everything is a relationship. What can have relationships? Well, on one end, it is a user ID. So if you have a Google account, you have what is called a Gaia ID, a 12-digit number. You can look it up. So one has to be a user ID, and the other can be any object. It could be a YouTube video, a Google group link, a Google Doc, a Google photo, anything, any object. And there is a relationship between the user and the object. And what are those relations? It could be like member of a group, editor of a document, uploader of a video. Say tomorrow Google makes a new product, they have to just define a new user and object and the relation between them. So we have users, we have objects, we know how they're related. How do you tell a system, a computer, that this exists? The paper describes this thing called a relation tuple, which is a format to specify a relationship. Now, how to read this is start at the hashtag and what's on the right of it. So user number 3 is the owner of document 123. So suppose Sohan, I create a new document. It would say user Sohan is the owner of document 123, and it would write it in the backend. Now this is it's very flexible because objects can relate to other objects, but objects can relate to other objects' relations as well. So in this case, say group security is a member of group engineering. Think of a time in your company there's been a reorganization. One team has moved to another. In very large companies, this is complex. You have to change logins and access and LDAP. But in a system like this, it's about just writing a new relationship. You would just write, group security is now a member of group DevOps. And everything else would fall into place. So it gives Google the flexibility to model all their different use cases at scale. So we have all this data. What are we really doing with it? So in the backend, what happens is essentially a graph is created where every user and object is a node, and so are the relation. I'm going to take the example of Google Docs, something we've all used. And how in Google Docs there are readers, so in this case Fred and Kim, and there are writers of a document, so in this case Jill. The important thing in this diagram is this little dotted line here, which says that anyone who's a writer of a document can read the document as well. So when a relationship is created, a graph is actually created in the backend. And if you've studied computer science or computer science theory, you know that parsing a graph is a very efficient way to actually run operations. So say, for instance, you have a new requirement to add an organization to a document. It's all about just adding a new relationship, which in the backend adds a new node in the graph. So you say organization, this is the name. You can add a relation called admin of an organization, in this case Niv, and a little dotted line from writer to admin. And we already know anyone who's a writer is a reader. So if anyone is added as an admin, they can both write and read this document. So this was a very interesting new way to do permissions and authorization, released in 2019. And this took the tech world and the IAM, Identity and Access Management world, by storm. Everyone's like, whoa, this is super cool. In fact, companies like Airbnb, they re-architected their entire authorization to model this, and they still do. And at the same time, there were also open source products that built using this, right? So you have a white paper, people can build open source based on that. And the 4 popular ones, wait, I'll get to that were built were these. So SpiceDB, Ori, OpenFGA, which you see here, and Permify, right? So they were based on the Google white paper. They built an open source product. And I will show you a quick demo using SpiceDB. Full disclosure, this is it's an open source product the company I work for helps maintain, but there are contributions from GitHub, Reddit, Netflix, etc., all of them who use SpiceDB in production, right? Because it is open source. And of course, as developers, what's the one metric that is the most important to all of us? Anyway, GitHub stars. Yeah, so we have 6,000 GitHub stars, but we could always use more. So if you're in the mood, please give us a like. I'll actually tell you a little bit about how SpiceDB works, which is exactly how Zanzibar works, with a demo. The idea is SpiceDB mirrors what was written in the Zanzibar paper. SpiceDB is essentially written in Go, and it is a graph database. So it's not a general purpose database, even though it has DB in the name. You can't store it, you can't use it to store records and company info. It's only meant for authorization queries. Does someone have permission to do something or not? For us as developers, it is basically a gRPC or a HTTP API, right? You just say, can I get permissions? Who has permissions? That's it. That's all that you need to know. And the API does 3 things. The first one is something called a schema. Remember when I said users and objects? Well, a schema is exactly that. You define the users and objects in your system. This doesn't have to be documents. It could be anything. It could be in finance. It could be in AI. You just model how your system looks into this schema. So I will show you code because we all like code. I have a SpiceDB version running in my browser right here using WebAssembly. So I'm like, okay, I want to build something like Google Docs. So what are the users and objects? Well, I define a user and I define a document. And then you have to define the relation between the users and the objects. So in this case, a user can be a writer or a reader. And once you define the relations, you can define the permissions associated with each relation. So you can say only writers can edit, but both readers and writers can view. Say the requirement changes, someone's like, no, we want to add a permission to also be able to comment on a document, again, like in Google Docs. So it's simple. It does not involve re-architecting your entire code. You just add a new relation like this, saying commenter, and you add permissions for a commenter. So I can say who can comment on a document. A commenter can comment, and a writer can comment as well. And a commenter has to be able to view the document too. So it actually becomes pretty straightforward to change your authorization in the backend for any use case. So that was the first one. We have users, we have objects, we have to write relationships. Remember I told you about the relation tuple. So anytime any action is created in the backend, like say someone creates a document, you can add this tuple or this relationship tuple to your backend. So again, going back, you would typically add relationships like this, right? So say document 1, user Tom is a writer. Or document 2, user Tom is a reader. Document 3, user Sohan is a writer. And I can change this to commenter as well. So I'm adding relationships to my backend. And anytime there is any change, like say someone creates something or a permission changes, you write a new relationship. All right. And the last thing you can do is, of course, a permission check. So how does a permission check work? Well, I will show you exactly how a permission check works. Say this is the permission check. Can you check if Jill has read permissions on some document? Have you ever clicked on a Google Docs link and seen the access denied? This is what's happening in the backend. If you can traverse the graph from some document to Jill via reader in a unidirectional way, that means Jill has permissions. So in this case, the answer is yes, because you can go some document, reader, writer, Jill. So that means yes, Jill does have permissions to read this document. Say a check comes in to see, is Fred a writer of some document? If you look at the graph, there's no way to go from some document to writer to Fred in a unidirectional way. So that means Fred does not have permissions. And again, if you've ever clicked on anything in Google, this check is probably happening somewhere deep in the system. So you can do this with SpiceDB as well. I'm just going to go back to that slide here. So you can make this check permission request to see if someone has access or not. With SpiceDB, you can also do lookups. So you can look up all the subjects that can access some document. So you'd be like, give me all the readers of some document, and it'll give you all these lines here, all these names. Or you can do a reverse lookup. You can be like, give me all the documents Fred has read access to. And typically this graph is huge, so you'll get all the documents. I'll again show you an example in the playground. Typically you will do this using code, but I'm showing it to you via the terminal using a CLI tool. So I will say Z, this is our schema. This is what our schema looks like. So I can do a permission check, right? Let's check if document doc1, there are read permissions for user, sorry, I think I called it view permissions for user Tom. And it is true, because we know that Tom is a writer, right? And we know that all writers can view the document. Yeah. I can even add this explain flag to see how the check happens. It checks if Tom's a reader. It's like no, but Tom is a writer, and writers can read. I can even do the lookup, as I mentioned. Permission check. Lookup resources of type document view user equal to Tom. Right? So if you go here, you can be like, Tom has access to document 1 and 2, but not 3. And that is what is being returned. So again, when you open your Google Drive and you get like a bunch of documents that you see listed, there is some sort of check like this that's happening in the backend. All right. The question I get asked when I explain all of this is, okay, sounds good, graph, relations. How does this actually scale? You know, we are talking about billions, millions. That is an entire talk in itself, I think. But I'll give you the shortened version. There are two main things that happens in the backend. One is everything is broken down into sub-problems. I'll show you what that means. And there is aggressive levels of cache that actually is here. And Google tries as much as possible to reuse that cache. So let's see what we mean by both of these things. I'm going back to our old example again, right? We have this. Now this is actually a union of three problems. It's a union of whether Jill's name is here directly in reader. It's a union of whether Jill's name is here in writer. And it's a union of this problem. So basically, if the check comes to see if Jill can access this document, you are already computing these problems. Is Fred a reader? And what's the name here? Is Kim a reader? And so on. So all of those sub-problems results are stored in the cache. So say the next time the permission check comes for is Fred a reader, you already know the answer. Yeah? So everything is broken down into subproblems and cached in the backend. To further improve speed, once you get an answer here that, okay, we have Jill's name here, the subsequent checks aren't actually made. It's like, okay, stop everything because this answer has to go back as quickly as possible. Remember this because I'm going to come back to this later on. Another question I get asked, okay, all this is good, but here's the thing. If you cache so much, what happens if something changes in the backend? Like say we remove someone's permissions and you use something from the cache and someone accesses a document they're not supposed to. So Google describes this in the paper as something called the new enemy problem, which is exactly this. If I have access to a document and say someone removes me from that document and makes changes and I try accessing it immediately after and I see something I shouldn't, that shouldn't happen. That is a security risk. And that's what I've described there as well, where at T1, Lex is removed, at T2, secrets are added, at T3, Lex tries to read that document, and he's able to do so. Right? This shouldn't be happening. To solve this, Google introduced this concept of what they call a Zuki. It presumably stands for Zanzibar cookie, but they don't actually mention it. But every change is actually accompanied by a thing called a Zuki, which is a timestamp of when that happened. So say someone creates a new document, there is a Zuki added to that timestamp. Right? So you know exactly what is created when. Say my name is added as a viewer of a document. In that call, the timestamp is added. Say I remove someone from a document, to that call, the timestamp is added. So you can use this timestamp to say, give me exactly what is fresh up until now. And you can say, hey, for me, I want something that is really fresh as of this point in time. I don't care about latency. It'll do that. It won't get stuff from the cache. You can be like, I want something super fast. I don't care about freshness. So then it'll get from the cache. And all of this is part of the API, which makes it extremely powerful. Okay, so I'm going even more into technical depth now. Again, to get at Google scale, there are a bunch of optimizations that they do. And a line from the white paper says, we found the handling of hotspots to be the most critical frontier in our pursuit of low latency and high availability. Also, authorization is on the critical path. Before anything can be done, you have to make an authorization check. When you type github.com, there's an authorization check going to every repository that you can have access to before it shows up on your page. So it's very critical. There are 4 techniques that they describe in the paper, right? The first one is called a distributed cache, which I explained to you. All the results of previous reads are stored and it's distributed among the entire backend. And they use something called consistent hashing, where there are multiple versions of Zanzibar running in their cloud. Each of them know which ones have which sub-problems. It's very smart. So if one node has done a bunch of computation around one problem, the next problem will automatically get routed to them because it can pull it from the cache. And that's what consistent hashing basically does. 2 is, I spoke about timestamps earlier. They actually very smartly round up timestamps. So it's not like for every nanosecond there's a new timestamp which would create a lot of timestamps and a lot of Zukis. They round it up in what they call a quantization window. So a bunch of requests will actually share the same timestamp, and this improves their latency. They use RPCs, or remote procedural calls, and they cache both on the end of the caller and the end of the callee. And in Google, they internally use this tool called Slicer, which automatically does load distribution when RPC calls are being made. And lastly, they use lock tables. So this actually is very interesting. So suppose 50 people try and access one document at a time. Now, instead of all 50 doing the whole graph and checking, they basically let one access the graph, and let the other 49 wait in a lock table. And once the one person accesses it, the cached result is given to the other 49. Right? And this is a cache stampede problem. It's like all of us rushing through the door. There's no space. But if we go one by one, it's easier. And that's essentially what happens with the lock table and Google Zanzibar. So these are hotspots, but what about the really hotspots? Like say a video goes viral, or say a document is shared with the entire organization of 100,000 people, everyone's clicking on it, what do you do then? There's some very interesting thing that Zanzibar does, which is the opposite of what I told you earlier. So when it detects an object is super hot, like it's gone viral, it actually does a full read of this entire object. Right? So assume there's some document 1, 2, 3, 4, 5. The entire graph is read, and this takes more memory and more bandwidth, but then all those results are cached. So the other people who are accessing it can access it from the cache. And remember when I said if we find Jill is a writer, it cancels the rest? But here, it doesn't do that. Right? It lets all the checks happen, because then people can actually access it. Because what if Niv tries to access it immediately after? So it delays this cancellation of sub-checks to make sure that requests are served with super low latency. That's how it works. And from the white paper itself, they say these techniques prevent 500,000 RPCs per second from creating hotspots. That is an insanely large number, right? Because all of these optimizations make it so scalable. Now, where would you use a Zanzibar-like system? Well, I think when you need something low latency, when you need scale, like I'm talking global level scale, a complex environment like in any enterprise, and you have a high throughput of authorization checks. Like I said, GitHub is a great example. Everything has to be checked. And you have a model with lots of hierarchies, lots of connections, lots of relationships. That's when a Zanzibar-like system really shines. Like I mentioned, companies like Airbnb and Carta, they restructured the entire team to use Zanzibar. Any Google Cloud users here? Yeah, okay. Google Cloud IAM is a fork of Zanzibar, right? It's literally a fork of the Zanzibar internal authorization system. At our company, we work with companies like Workday and Matillion, lots of banks and Fortune 500 companies who have these complex use cases where, permissions can be tricky at scale. In fact, this is probably a tool all of us use. Who here doesn't use ChatGPT? I'm sure all of us do. There's a new product in ChatGPT called Connectors, where like if you click that plus, you can connect Google Drive and SharePoint and Dropbox and do it in organizations. That uses SpiceDB, right? Because they had like 37 billion documents to actually process across 5 million users in organizations, which is a tricky problem. So they use SpiceDB and authZ dedicated, which is infrastructure we offer, to do this. And if anyone's in the AI space and has heard of like RAG pipelines, retrieval augmented generation, that's what OpenAI does with ChatGPT connectors. So at scale, when you want low latency and high throughput of checks, something like any Zanzibar-like system is a good option for you. And the reason, and the reason I'm telling you all of this is, has anyone here heard of OWASP? Few of y'all, of course. I feel if you've checked in enterprise code at any point of time, you've heard of OWASP. For those of y'all who aren't familiar, it's an industry body like a foundation, and they essentially do things like create lists of top 10 risks for web apps, for LLMs, and so on. And they do this list every 3 or 4 years. The next one should be out soon. But the number one in their critical security risks for web apps right now is broken access control. Right? Because over the last 10 years, I feel use cases have become complex, environments have become super complex, which makes permissions and authorization super hard, makes access control hard. We see, 10 million documents breached, records breached so often in the news now. And that's because authorization is a hard problem. And maybe a Zanzibar-like system is useful for you, but look at how you can improve that aspect. All right. For next steps, I would say read the Zanzibar paper on the way back home. Maybe if you want a good technical read, I would recommend it. It's a fun read. The demo I showed you on is on play.authZ.com. It runs a SpiceDB binary written using WebAssembly in the browser, just for you to like play around with. Of course, SpiceDB is open source, so feel free to jump into the community, try it out. We have people who use it in production as well. And yeah, you can learn more on YouTube, docs, and so on. Cool. I only hope you learned something new today. That is my one hope. And if you want the deck, you can get it emailed on that link, this exact deck that I presented. Feel free to connect with me on LinkedIn. But yeah, thanks for hearing me, and I'm here for questions.
Yes, thank you for the presentation. I have two quick questions.
Yeah.
One is, well, throughout the presentation, you said multiple times that this project scales very well, but I would like to ask about something very opposite. Is this project usable also for small applications, or is there some like inherent complexity which makes it unadvisable to use for small applications? That's the first question. And second question is, was there some interesting security issues do you remember and you can share with us? Thank you.
Okay. Yeah. I'll answer the first part of your question. It is absolutely suitable for smaller projects as well. The inherent complexity comes in the sense that you have to maintain and write the relationships. So in essence, you're doing what's called a dual write. So say you create a document. In your backend, you have an API call to create a document. You'll also need to add an API call to create a relationship between the user and the document, right? Or it could be any use case. So this is not a solution that is a drag and drop solution. It's not like you just drop it into your project and you're done. You know, it involves some sort of rewriting of code and some rethinking of how it looks. But in a small project, that's the best way for you to learn when that project eventually scales and becomes more complex. You know, so 100% that. To your second half of the question, I think over the last few years, we have seen lots of data breaches purely because of things like the new enemy problem. You know, how companies do authorization now is basically mostly custom authorization. One is they have a table and they write like hundreds of SQL joins, not advisable. You know, that can crash a system, not at all advisable. The second one, and this I'll tell you why I'm laughing, is people use JWT, like a JOT token. And in the scope, you try and add like as much authorization as possible. You store it in a database. You try with like refresh and stuff. That does not solve the new enemy problem. The reason I'm laughing is I made a YouTube video saying don't use JWTs, and I've never got more hate in my life in the comments. You know, you can check it out. Everyone's like, no, this guy doesn't know anything. But you cannot meaningfully revoke a token once it's passed through a JWT, right? And the new enemy problem is exactly that. And yeah, we've seen, I think it was maybe a year ago that Toyota had like this problem where they have like dealerships, and again there was some authorization problems. So using and login of a dealership, people were able to get access of their entire backend systems and stuff. So too many cases basically of things like this, which is why I think centralized authorization should be at the top of at least enterprises. Yeah, honestly, you can just model that in your schema. Like when I'm defining a schema here. This doesn't necessarily have to be like a logged in user. You can define like, okay, this is also an anonymous schema. The great thing about schema, and I would have loved to have gone into detail, is it is very, very flexible. So for instance, when you mentioned a document in a folder, you can actually have like a arrow to point that, okay, this resides in a folder. You can also use things like plus and minus and intersection to do that. You can also add something called a caveat, right? So this is interesting, and I'll give you a bit of a story. So the Zanzibar paper did not have like a thing for anything dynamic. Like this was, the user can access this only on Tuesday, right? And the original Zanzibar paper didn't have that. You needed to know relationships beforehand. So Netflix were actually interested in using SpiceDB. So they contributed this caveat, which gives you like a dynamic option to SpiceDB, and they're using it in their production. So I say something like, oh, use this only on Tuesday, and in my document, I say, okay, I'm defining the relation between the user and the document. So user is a reader, but with the caveat that the user can do this only on Tuesday. And it's super simple, right? If you are to write code for something like this, it's like another library. You have to maintain it, you have to test it out, you have to do time zones, whatever. But here, if there's a new thing which says, add Thursday as well, it's just about changing your schema, running a bunch of relationships, and doing it. So I think that flexibility is how Google thought of it, because they have all of these products. So yeah. No, so you'll have to make that call to the SpiceDB API. So the SpiceDB API gives you all the CRUD options, so you can update a relationship as well. So suppose you delete a user from a document, you will make a call saying delete this relationship between this user and so you have to make that call. And that is the added, I think, complexity that we spoke about. That it's an added API call to a lot of these things which affect your relationships. When people ask me, okay, I have this system and there's no authorization and I want to move to SpiceDB or a Zanzibar-like system, what's the migration? It's not like a single click thing. I try and explain to them it's like migrating to the cloud. If folks were there like maybe 10 years ago, we'd say, okay, you don't have something on the cloud, move a non-essential workload to the cloud, learn something, then take your essential workload to the cloud, right? So in a way, it's kind of similar in terms of re-architecting your system to build for like a Zanzibar-like system, yeah. Cool. I'm here for whatever. I'm leaving back to Amsterdam tomorrow, so I'll be here all evening. If you have any questions, if you want to chat about maybe your use case, if it's worth it, feel free. I'm around. And just check it out if this thing interests you, and hope you enjoyed the conference. Thank you.